Alright guys, so we've gotten the very basics under our belt. We've created our Hello World program and we've learned how to compile our program via the terminal. So now what I'm going to go ahead and do is create a new program. And before I go ahead and start writing to this program, I'm going to actually name it. So close that and I'll name it by saving it. And I'll name this program cool.c. And where am I going to save it to? Well, I'll just put it on my desktop for now just to give a visual representation as to where it is and all that. So if I go ahead and look at the desktop, we can now see that cool.c exists. There it is. It's happy. It's having fun. But let's actually start making this program do something, because now he's a little bored and a little lonely. He wants some text inside of him. So we'll include the library that we've been using by typing in hashtag include, or rather pound, sorry, us millennials or whatever you want to call our generation. So we'll include the standard input.output library by doing that, and then I'll specify that the return type is an integer, and of course every C program starts with this main function, and then I'll do that. This is just the skeleton of the program, and you should just go ahead and get used to typing this every time you create a C program. So now we'll go ahead and pass in some variables. This is something new. So I'll kind of relate it to algebraic variables. However, there's of course differences between variables in programming and variables in algebra. But let's say like in algebra you have the very basic variable that we all start off with named x. And the value inside of x is going to be initialized to 10. So this equal sign right here does not mean, hey, this x is equal to 10. Rather, what this single equal sign specifies is that we're going to put a value of 10 inside of x. So again, if I were to pass in something like x is equal to 11 right here, well, it's not saying that x is x is not actually 11. This just says x gets the value of 11. So right here, this program is changing the value from 10 to 11. So it's just assigning a value inside of x. But just, I've actually been writing code wrong right here just to kind of give a little explanation. We need to specify the type of value that is going to be inside of x. And since we see a whole number in here, that already gives us an indication that this is going to be an integer type. Integers inside of programming are usually these whole numbers like 0, 1, 2, 3, 4, whatever. There's going to be no there's going to be no decimals inside of this variable. So let's say we wanted more than one variable. I wanted another variable named y, and I wanted y to contain the value of 5 inside of it. So again, I'll pass in specifying that this is an integer type variable. Other programming languages, you may see something like var x is equal to 2.3 blam. Well, that's called implicit casting right there. We're implicitly saying that this is a float type. But in C, you have to explicitly say, hey, yo, this variable right here is going to contain an integer inside of it, or something like that. So now what we want to actually do is go ahead and print out by calling in the printf function these values to the screen. So I'll type in, just to let people know, my variable is x, because that's the first variable that we want to display, and has a value of bam. Well, now we need to actually write the value of whatever's inside of this integer to this text line right here. And the way we can do that is by passing in %d. And what this does is it tells the computer, hey, I want to display right here an integer. And the computer right away, because as you see, we have two integers right here, and even if we only had one integer, the computer needs to know exactly which integer you want to display on this line of text. So I'm going to say, hey, the integer that I want to display is named x. So the %d specifies, okay, integer. Now let me know what integer that is. So I'll type in x right there. And before I go ahead and compile it, I'll put the \n so we get a new line. Zoom out, and I'll open up the terminal by pushing, give me a second here. I'll open up the terminal by pushing Command space, typing in terminal, pushing enter. Changing my directory to desktop, and again, if you guys aren't familiar with these commands here, you can check in previous videos where I go over each command in depth. I'll push ls to list the contents of this directory, and I see that there's my file called cool.c. Now let's actually compile this using our compiler gcc, and then typing in the C file name cool.c. But if I were to just compile it this way, I would get a file, an executable file named a.out. I don't really want a.out because it doesn't tell me a lot about the file, and what's more, it's going to write over the previous a.out file that I've created. So I'll pass in -o, followed by the name I want the file that I'm creating to be called. So in this instance, I'll name it cool. I'll just name it cool, and I'll push enter, and you see that the file is compiled, and that was fun to say. And if I go ahead and list the contents of my desktop, I now have a file named cool, whereas previously I didn't have that. So if I open up cool by pushing or typing in /cool, push enter, I can now see, hey, my variable is x and has a value of 10. Well, that's true, there's no lie about that. But let's say now that I want to print the value of y, I can of course go ahead and copy that line, paste it, and instead of having my variable as x, I'll pass in y wherever I see x exist. Go back here into my terminal, and I will recompile the program by quickly pushing up on the arrow key, and I can see that I can view the previous commands that I typed in the terminal. I'll push enter when I stop at the GCC, overriding the file that we had once previously named cool. Now if I go ahead and see what the contents of, or rather I start the program cool by typing in /cool, I now see my variable is x and it has a value of 10, followed by my variable is y and it has a value of 5. This is awesome, but let's say for instance I wanted to have this all on one line. How am I going to display multiple variables on the same line? Well, luckily it's not that difficult in C, and instead of having a different line, I will now pass in my variable is y and has a value of %d. So I need to specify right here that the first integer, because the computer is going to read this from left to right, it's going to go, okay, I see that you want me to insert an integer, so the first one that I'll insert is x. And then it's reading, okay, I see you want another integer. Now I need to know specifically what this integer is. And I could pass in x again if I wanted to, and that would just display my variable x has a value of 10, my variable y has a value of 10. That's not correct though. Instead I'll pass in y because we want to get the corresponding value, or rather the value which corresponds to y. So I'll zoom out. Now I'll bring up my terminal once more, and if I go ahead and push up on the command, if I push up on the arrow keys and push enter to recompile the program and rerun the program, we see that the programs are identical in when we run it, but however the implementation behind the scenes is a little different. And this is known as a term called abstraction, where the user gets the same experience, however the implementation is done in a different manner. So that'll be this for this tutorial, guys. In the next tutorials, we'll go ahead and start doing some math with these variables and manipulating them in various manners, as well as displaying different variable types and stating their corresponding values in terms of memory. So go ahead and give me a like and a subscribe,